Okay, let's look at page 268, problem B3. In this problem, we're supposed to be showing that, from these instructions, show that the following pairs of sentences are not logically equivalent. And so for B3, they give us the following pair. They give us for all x, rxx, and there exists x, rxx. Now, I guess those parentheses aren't necessary there, but it's not a problem to add them. So I need, what does it mean to show, what does it mean if they are logically equivalent? It would mean that in all interpretations, these two sentences take the same truth values. But we're trying to show they're not logically equivalent, which means a single interpretation will have to make one of them true and one of them false. Okay? So that's what I'm going to do. I'm going to create an interpretation for all of our predicates here that make one of them, and I have to choose a domain that makes one of them true and one of them false. So let's make the domain Tom and Lydia. So Tom is me, Lydia is my toddler, and let's let the predicate R of xy mean x cooks for y. Okay, so that is my interpretation, and let's look at the truth values of these two sentences. So for all x, rxx, this is false, because as I pick x to be different things in my domain, sometimes it's true, sometimes not. It's false specifically because if we extend our interpretation to allow L to stand for my toddler Lydia, then RLL is false, right? Lydia does not cook for herself, at least yet. So since it's false for at least one thing in the domain, that for all x, rxx ends up false as a statement. Now, there exists x, rxx. This is true. And it's because existential quantifiers only require a single thing in the domain to be true. So if I can't take t because t is a variable symbol, so if I took a to be Tom, then RAA is true. So there is one thing, at least, in the domain for which RAA, if I set x equal to that thing, is true. And that's it. That's all we had to do. The book makes this very complicated because they focus, and a lot of the complication comes from, introducing a new symbol once you're in an interpretation. Okay, I guess we could have done that with our, global interpretation, but we don't need it for those particular sentences. It's once we started working with the sentences that we needed to introduce a symbol, and this is very common in mathematics. Okay, so you'll get used to it, but technically, when I added this symbol L or this symbol A, I was actually extending the interpretation to sort of a bigger one. There's more assumptions there, but that's what you have to do to relate a quantifier to a specific case of that quantifier. And I don't think the book does a super great job explaining that, but I think in practice it's kind of clear what's happening, right? You're saying, in this case, I found something, I had to give it a named constant to plug it into the predicate. Or here, I found something, I give it a symbol to plug it into the predicate. That's really what's going on, and if that's your understanding, you're fine. Okay, now I'd like to look at problem B4. Problem B4 is the same kind of question, except now our sentences of first order logic are there exists x px implies qc. Now notice that existential quantifier, its scope stops there. Okay, it does not include everything. The other one is there exists x, px implies q of c. So notice there the scope of the existential quantifier is everything. So that's the difference between these two sentences. They're deviously similar looking, but they are different. So how am I going to do this? I think the following will work. If I take the domain to be a platypus and a skink. Now, if you don't know what a platypus is, go Google it. They're strange animals. They're egg-laying mammals that that have poison spines. They're ridiculous. They look like a cross between a duck and a beaver. A skink is a type of lizard. We even have those in West Virginia. So it's some kind of reptile. So I'm gonna let P of x stand for x is a mammal. Okay. And I'm going to let Q of x stand for x is a planet. Okay. Now Q is false for everything in this domain. P is true for the platypus, but not true for the skink. And I think this will do it. Now I also have to let C be something. Since Q is always false, it doesn't really matter. So let's let C stand for the skink. Okay. So that's my interpretation. And so let's go ahead and look at these two sentences. So there exists x, px implies q of c. Now, q of c is false. So we have a false there. There exists x, px. So the question is there something in my domain such that p of x is true? The answer is yes, right? The platypus. So if I let A stand for platypus, then I would have, P of A here, and that's true, right? So I have a true implies false. Well, that's false, right? Because that's how implies works. So we have an interpretation in which this first sentence is a false, okay? So we successfully found something for the there exists, which if there is one at all, you have to call it true. Then we got the false. Now, on the other hand, there exists x, px implies q of c. Well, again, we're kind of forced to have, that's false. I'm not using capital F as a sentence letter. I'm just kind of thinking through the logic here. Now, the question is, can I pick an x in my domain that makes this implication resolve to true? And the answer is yes, I can. I would pick B to be the skink. And then I would end up with P. I could pick P of B implies, false. In other words, false implies false, and that's true. So, the placement of that existential and its scope matters. When I picked platypus here, I was trying to make this part of it true. And I did, okay? Because that's, that sentence alone, that's what it does. But here, since the existential quantifier is among all this stuff, what I'm seeking is a value of x in the domain that makes the entire sentence a true. And I was able to accomplish that by picking one for which P was false. I didn't have that luxury here. And that's really the technical difference between these two sentences. In this one, you're forced to pick an x in the domain that makes that true. But here, you're forced to pick an x in a domain that makes the whole thing true, which gives you more freedom over the choice of the x that goes into the P. So that's a subtle thing, but interesting example.